right, so here's what we got. So for all you at home, there's already six. I'm 2 periods in. Anyway, I'm going to put this video online. We showed how tangent slope and blah, blah, blah. I feel like it'd be illegal to play her video on my video, and then I'm like claiming it. And then, I get sued. All right. All my teaching money gone, gone. All right. Okay. So what we learned from that is stick these things in your notes now. All right. And I did a 2-in-1 sheet again because I saved 62 pieces of paper. Good for you, Mr. Samuelis. They could have saved us another 62 by giving us nothing. All right. Anyway. Okay. So tangent is slope because tangent is sine over cosine. Sine, remember, in a unit circle is the y value. Cosine is the x coordinate, in a coordinate plane for a unit circle there. And then I just made up some numbers. This one isn't made up though. When we're in that first position, now just imagine the animation. And we're moving along in this animation, pulling that point on the unit circle and then input outputting. And then I made this up. That one looks like about 1/3 as a slope. Right. And then this one's not made up because that does look like 45 degrees. And I just showed you on the other animation where you get to play with with the graph yourself. All right. Tan of 45 is 1. And then I don't know. I just made up maybe around 3, maybe around 6. And then when you hit here, that's an undies. You're undefined when you get to 90 degrees. So that's why I put that in that blank there. Vertical line slopes are always undefined. For a chart of values, that turns into an asymptote. All right, and we'll put that down later. And then moving along the unit circle, go ahead and just stick these made up values by Mr. Samuelis. When she was on this, her first one was like -14. I probably should have put that and coincided with the lady. But I just made up some. So negative steep, then -3-ish. That is right in the middle. So that's 135 degrees. We made a mistake by not doing degrees with you. I know that's also 3 pi over 4 radians, but that's a 45 in quadrant 2. So it's 135 degrees, that angle measure right there. And that slope is -1. And then I did not make up that one. That is 0 for sure. Right? Input, say it. So that's what we're getting. Those are output values, those M values, right? When we go to a chart. You're not going to be doing that. I'll show you the key values. We're going right to the key values. One more quadrants, and then we just kind of gave up, all right? The lady did a great job. 1/3. That kind of is not in the middle. I wish it was, but let's pretend it's in the middle. Then we could say that slope is 1. And then just made up, steep, steep, until we get undefined yet again. We get the cyclic thing going on, this periodic stuff that we have. Okay, and then we just ignored quadrant 4. So key concept, each time the terminal ray is vertical, the slopes are undefined. That turns into a vertical asymptote. I'm not like correcting the lady, but I kind of, wanted you to understand why there's an asymptote here. It's because of the behavior before and after. The slopes get so steep, they essentially become infinity right before you get to those asymptotes, or negative infinity, depending on what side you're on there. So that is why we draw the vertical line to denote that behavior. All right, and that's the true meaning of an asymptote. It's made up by humans to show that behavior on a chart. Okay, but anyway, we're going to go to a chart now, and then I'll tell you why you're supposed to row. Where's the pen? No, I got to leave for a moment and search for my pen. You ever see the pen anywhere? No. Wow, I really tried to mess with myself there. Okay, everyone okay? A lot of stunned looks at me like I'm strange every day teaching in America. All right. So, as I was saying, as I was walking around like an old confused man trying to find my pen, input, say it. What's the tan of 45? 1. What's the tan of 0? What's the tan of 0 here? Oh, this is what I did with the crazy kids last hour. I did this, ASTC, right? ASTC, that's who's positive and who's negative. And then the question I ask is, what's the tan of 0 radians? Which 0 radians has this coordinate, x comma y. What's y over x? 0, right? And then let's go positive. Pi over 2, that's 0 comma 1 rut row. What's y over x on that one? Undefined. What happens at undies? An asymptote. And then 3 pi over 4, that was this value right here, the 45 in quadrant 2. S means sine's positive. That means tan is negative. All right? And then at pi, same thing, but negative 1 comma 0. 0 over negative 1 is 0. And then 5 pi over 4, the 45 in quadrant 3. Tangent's positive in quadrant 3. Right? These are the values you're going to mark up. All right? And then we're going to understand, hopefully, what happens at asymptotes. Then again, this is 0, negative 1, but you still get 1 over 0 undies. And then 7 pi over 4, and then 2 pi lands right back at the origin here. But here's really where I want to graph. This is the same as this x value. You're just going clockwise quicker to negative pi over 4, so you'll get the same output value. And then negative pi over 2 is the same thing as 3 pi over 2, undefined. I'm going to highlight this right now because this is really what we're going to concentrate on with 1 period worth. You know, that part is the most important part for a tan graph. The lady tried to show it. She started pulling backwards, but then she stopped. And then I just kind of filled in the missing parts there. And then negative 3 pi over 4 is actually in quadrant 3. And then this is back to 0. All right, so then when we go to this, problem with this is here's where the asymptotes are. So we'd have to mark this with our, and this is how this is going to happen when we change the period. You just got to be able to take half of pi over 2, which is pi over 4. All you got to do is multiply the denominator by 2 if you've not figured that out at this point. All right, and then this is negative pi over 4. I'm going to flip this sucker up here because I know what these points are. This is the 1 value. This is the negative 1 value. That is the 0 value. Then the idea of the asymptotes is, well, this is what happens. Input, output. When I plug in this x value, you're way up here. That showed that in the animation. I think the highest slope that she saw was like, actually I saw some in the 50s. If I would have noted it, she did get pretty close, like really, really high numbers. All right, and then that's why that occurs. All right, pi over 2, then 3 pi over 2 is our next asymptote. This is a 0, and then we won't mark these, but if I had to, 1 pi over 2, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So again, only the fractionally challenged cannot fill in those values because that's all it is. It goes by over 4s, and it is not and should not be things that are stumbling us. Really, really, really shouldn't be. Right? And then this is just another half of a tan graph, and then 3 pi over 2 negative, and then 0, you can see the chart values that go along with this. Let's get it all done here. Right, and then this is a 0 again, and then this is a 1. Now, all right, so what is the length of 1 period of tan? We already said it, pi. You already mentioned it. I don't have to ask you again and get a bunch of blank stares looking at me. All right, does amplitude make sense in here? Is there a high and a low point? Yes or no? 3, 2, 1, go. No. So there is no amplitude in a tan graph, and you'll find out in a cotan graph. But we will say what is A. We do need to know the stretch shrink factor of those little quarter points, I like to call it. So we're going to graph 2 different ways. I'm going to graph from 2 pi to negative 2 pi, then I'm going to graph 1 period's worth because I'm going to fight the other teachers that we do that on. And we did have that on the last quiz or test. We had to graph sine and cosine for 1 period. And I did 3 different times where we graphed that in a, building up to that. So it shouldn't have been a big deal. All right, I got 2 different things I got to do here. Let's highlight this in yellow. Here are the equation of all the asymptotes, which I believe Yeah, I'm waiting for the next page on this. Okay, so what we got to understand is I have a period of pi, but then I literally told you the asymptotes are half a period left and right of that zero value. So where are they located? First of all, an equation of a vertical line is x equals. Okay, we got to reiterate that. Some people flip coins and still don't have that down. All right, show at this point. And then where is our first asymptote? You can pick. You can pick any one of these. You can pick this one, this one, this one. You have an infinite amount of choices as this goes off infinitely. But usually we like picking the first one that is positive. So the first asymptote I see is x equals pi over 2. And then here we go. You've already been trained at this in this class. How far is every asymptote away from each other? The starts with a P. 3, 2, 1, go. Period. And then it could be pi n or pi k. I think I kind of like n better because k looks like x's a lot of times. I don't care. All right. Some books use n, some use k. But then after that, let's get fancy and do that NEZ. What does that mean? N is an element of what subset of numbers? Starts with an I. IN. Integers. If I plug in 0, I get x equals pi over 2. If I plug in 1, I get 3 pi over 2. Look at your graph. That's where one of the asymptotes are. I plug in negative 1 for n, I get negative pi over 2. Look at your graph. That's where one of the asymptotes are. Now, why did I separate that from domain? I don't know what the others are doing. I know this is a valid notation. So I couldn't, anyone, care, anyone, less. Okay, and I guess I didn't really highlight that, but you got to give me a little different notation on this. And we should be aware of this, what a not equal to sign does mean. And that's not the first time I've actually used this. We've done this when we had vertical asymptotes in rational functions. So that means x colon, or it means x such that has these next conditions. And really what I'm going to write is the exact same thing I did for the asymptotes, except x can't equal these values because it turns into an undefined result. So x cannot equal that whole pi over 2 plus pi n thing. And then get all fancy with it, NEZ. And then you use braces to denote that notation. Should be aware of it. Not that you should know it. I think I got to expose you to that because it's a very common way of writing stuff, especially with the not equal to sign. So understand the difference between domain and write in the equation of lines. All right, and then what's the range? What is the range? What are the y values covered by one graph? And by the way, I did want to denote this in the charts. That's the one period from the chart that I highlighted, right? But what is, just look in that picture, what's covered for y? All, anyone? All reals. This is going to be an always. Never, never, never changes. I don't care what I do to the tan equation. This is it. All right. So now we get to the brass tacks of it. Here are some things. We're going to wait on a phase shift, right, left. We're going to get down the schematics of changing the period, and then up, down shifts are not that big of a deal. All right. But I want to make sure you put here, this is a vertical dilation, so I will ask for A, but there is not an amplitude. So you can never call it an amplitude because there is no high-low point. That's what amplitude means. I gave you a physics definition of that when we did sine and cosine. All right, so there is no amplitude, but I will ask for an A. It's a stretch shrink factor is what it is vertically. All right, and then we are going to shift it up and down. So that's what D represents up in the equation. So we're going to hold off on this. Notice the structure again of that equation, exact same structure of sine and cosine, and actually every function. Okay, every function. And then we could see that graph right there. Notice it increases forever. We do have inflection points. What I did with the other hour is I actually marked them with a highlighter. That's where it changes concavity, those zeros. All right. So we could highlight that. And it does change from concave down to the left of a zero, concave up to the right of the zero. But it's increasing forever except for the interruptions at the vertical lines. All right. So here are some things we have to consider. Right. So I just showed the vertical asymptotes where this is the equation of them. Right. So it's at those angle values. Pi over 2 is where you get your one of your first ones, and then they're a period away. But what happens when you change the period? When you change the period, this changes very, very specifically. Well, first of all, period, we already saw up there, comes from pi over b, not 2 pi. This is tangent graphs. They're very specific. So if I change the period, the asymptotes are a period away from each other. This is a definition, right? Something you're going to have to lock in. But then what did I say about the asymptotes? From the zero value, they are nobody. What do I, when I always do this noise, what fraction am I going to say? Half this way and half that way of the period. So they are literally half the period away from those zero values. Half. Okay, I'll prove that through input, say it, output. We're going to plug in some numbers to prove what happens with this simple graph here. All right, moving along a little faster. I hope you understand that the period is, in this case, pi over 2, right? B is 2. Okay, so now input, say it. When I plug in 0 for x, first of all, what's 0 times 2? Say it. What's tan of 0, everybody? 0 still. There is no change. That point is an input-output value. All right? Now, what happens next? Well, I just told you the period is pi over 2, so I must go half of the period. What's half of pi over 2? Pi over what, everyone? 4. Let's zoom in on that. And I am good right here. Watch what I do. I'm going to put this one above because I know what's going to happen with the values here. Now, all you have to be is not fractionally challenged, right? When I plug in pi over 4, 2 times pi over 4 is pi over, just say that number, 2. And then what's the tan of pi over 2? Undefined. So that's how the graph is actually horizontally shrunk by a factor of a half is what they like to say on that. All right, so that's where that is. And then we're going to zoom in even farther because I am going to have you do this. I couldn't care less. We do want those quarter values. So what is half of pi over 4? Pi over what? It is not hard. All right, and we are going to have you find those. I'm going to fight for it that we get these quarter values no matter what the period is. All right, why did I write that up there? Because these are the 1 and -1 values. All right, and now this is one graph, and I can prove it. I know I bore you. I don't care. I want to give you a deeper understanding that graphing is input outputting. So when I throw in pi over 8, 2 times pi over 8 is pi over 4. So when I plug in pi over 8 for x, I get pi over 4 after this evaluation. What's the tan of pi over 4, everyone? 1. That's why that's our new 1 value. All right, but here's the key. Pi over 4, 1 pi over 2, 3 pi over 8, 4 pi over 8. That's our next 0. 5 pi over 8, 6 pi over 8. Here's our next asymptote. So this is going to be kind of annoying to draw. We won't mark those other values. So we go every 1, 2, 1, 2, 1, 2. All right, and then to do this from 0 to 2 pi, we got a lot of curves we got to do. And then this is just this bottom one. All right, because of time, you could go ahead and do that. I'm just going to move on. You get the point. All right, graphing these from 0 to 2 pi sometimes can be annoying. All right, so what is our equation of asymptotes? Let's separate that. That's x equals our asymptotes at pi over 4, and it is the period away, n. Last hour I used z, It don't matter. So what does that mean for the domain? That's different. We'll use set builder notation for that. X such that X cannot equal these same exact values. That's an interruption in the outputting. You don't get an output for these. That's why that's called. And by the way, I don't know if I said this in the movie, a not equal to sign means it equals everything else but those. So that is covering the whole domain. Range always. And period we already found. I guess I was supposed to put it down in this position. Pi over b, which is pi over 2. Should we see that in the graph? Okay, let's move on. Okay, spent too much time on that. Now, I am going to do this just one period. This is what you were supposed to do. And again, when you're doing your homework and you look at the review, it's the final countdown to get ready for a test. In the review, I had a coordinate plane like this, and I cut it like into thirds and spread out the graph. All right. So that's what I expect out of you for this. This period is pi over 3 because b is 3. I'm going to tread lightly on my input outputting. I got to recognize that I have a negative, which is a flip, right? I'll write this down for no purposes. This is not an amplitude, but this gets stretched by a factor of 2. So we're 2 up and 2 down from our 0 point. But we are also moved up 1. All right, so I got to take that into account when I start putting my values. Here's what we're going to do. And luckily, we don't have a phase shift yet. Believe me, phase shifts are a big pain. But I'm going to do what I did on the, this kind of grid. I'm going to go by threes. Okay. And then we could just actually leave it at that. And then go by threes. And then this is going to be 1 periods. We could go by more, but you want to give yourself space. And this is where I get my critical values. So the period is pi over 3. So this is a period from here to here. That's what we have to get out of this, and understand that the graph is cut in half as far as what we got here. So what is this value? Pi over what? Right here. What's half of pi over 3, everyone? Pi over what? 6. And then what's half of pi over 6? What's half of pi over 6? Pi over 12. This is why I like this. It's actually a little bit cleaner, too, to graph one of these periods. Then we could spread it out. We could really see these values. It's all good. So I'm just going to graph 1 period. I'm not going to graph from 2 pi to negative 2 pi. That'd be even more annoying because that 3 there'd be even more curves from 0 to 2 pi. Just a lot. So that's why I like doing this as well. Okay, and then input, say it. When I plug in 0 for x, we're still getting something. 0 times 3 is, what's 0 times 3? What's tan of 0 still? Again, and if you still don't know that, I don't know what you're doing in here. You're licking the walls. All right, what's 0 times negative 2? 0, but then 0 plus 1 is what? 1. So there's our up 1, input outputting. So we got to be careful. Got to make sure we shift up 1 all of our next points. And then we do have a flip upside down. All right, not to bore you here, but when I put negative pi over 12 in here, maybe pi over 12 is better. Pi over 12 times 3 is pi over 4. Tan of pi over 4 is 1. 1 times negative 2 is negative 2. Negative 2 plus 1 is negative 1. So I just proved that this is 1, 2 away down. All right, this next critical value. Because I went by threes, we did kind of just, we're like zooming in on the graph by going by threes. All right, by happening. Pi over 6 times 3 is pi over 2. We know tan of pi over 2 is undefined. So that's why that happens and that happens. So the value of input outputting is enormous. And then if I plugged in negative pi over 2, I would get negative 1. Negative 1 times negative 2 is 2. 2 plus 1 is 3. So really should be understanding this. This is based on all of knowledge you're supposed to have locked in. All right? Okay. So domain, same old. Equation of asymptotes then into domain. So that's x equals first asymptote plus period k. Oh, I did k now. Now say k, ez. Books do either or. All right, it doesn't really matter. So then that means the domain is not that x such that x cannot equal these values because you don't get an output. Should zoom in. I'm running out of space here. Pi over 3k. Since I use k, k-e-z. And that's all you have to say, and then close that brace. Sorry, those got a little sloppy. And then range, never change. Ooh, poet, and I didn't even know it. Okay, we really should be able to do these next ones. Talk with your friends. How do you reverse this equation? How do you reverse the graph and get an equation? And then look at these two and see if you can get these answers. All right. I don't know if I can pause the video. I might just have to walk around. So I guess I could kill. I wonder if I can. Let's see. Let's see. Fumble. No, it's just to stop sharing. Technology. I'm stuck. It's time to get out of here. All right, you sillies. We literally graphed this one, didn't we? Well, actually, that's a lie. I skipped one. Oh, no. This one, this one, this one, this one. Okay, hopefully you got this one done. See those negative pi over 4 to pi over 4? So we literally, and see this? It is 0, 0, and then this is only one high and one low. So we do have an A value of 1. All right. So literally that was our graph, I think the first one of the day. 1 tan, 2x. How many people have 1 tan, 2x? Raise your hand. Nice. Okay, now go into this next one. This was horrible. Oh, he's so mean to us. But this was horrible on the sine cosine test. Horrible. What is b equal to when you see this thing here? Is it 3 or 1/3? 3, 2, 1, go. 1/3. It's not 3. It doesn't say 3x. Do you hear them? They're pounding on the wall because they're mad at you. All right. 1/3. Do you hear that pounding, right? Or is that just in my head? Okay. So b is 1/3. So this is pi over 1/3, which ends up being what? Is that 3 pi or is that what is it? Okay, so this is no, it's not pi over 6. Okay, so this is 3 pi, right? Not pi over a third. Remember, period is pi over b for this stuff. Okay, and then what did I tell you about asymptotes? The asymptotes are half of the period is where the first one is, and then a period away from each other after that. All right, and then it should say where k is a integer. I don't know why that says constant. I don't like that from the AP. We pulled that from AP, so I don't like that terminology. Is this the last one? Thank goodness. Then he'll shut up finally. All right, you ready? So we should see that this was moved which direction? And actually, I teach an SAT class. This is a valuable thing for multiple choice. Down to who's out right away? Who do you destroy? B and D. So you now got a flip of a coin, at least an educated guess flip of a coin. All right. But then the next thing is there they are again. They're pounding that wall. All right. Hopefully they bust through like the high C man. Oh, yeah. All right. So then that is 2 pi. And the period comes from pi over b. What do we do to find b? We switched. What's pi over 2 pi become? Not 2. 1/2. So what's the answer? Is it A or is it C? It's A. Down 2 and then a B value of 1/2. All right. Stop sharing. But sharing is caring.